Welcome to Spring LIB.
In this exercise, we have an electron that has a mass m and an initial velocity along the x-axis that has a value v0, so v0 is horizontal. And the electron is subject to a force that has x component F0 and y component 0.3 times F0, where F0 is just a constant. And our goal is to find both the equation of the path of the particle and the speed of the electron at any time. In order to do that, we need to remember some points. First, we need to remember that according to Newton's second law, the force, the sum of the forces in a particle is equal to the mass of the particle times the acceleration. Second, we need to remember that the acceleration is equal to the derivative of the velocity with respect to time. And finally, that the velocity, v, is equal to the derivative of the position vector with respect to time. And with this in mind, we can carry on with the exercise. So first, the first thing I'm going to do is to find the speed of the electron at any time. In order to do that, I'm gonna need to find the x and y components of the velocity. So let me separate the force into two components. So I have that Fx is equal to F0. Now notice that Fx is equal to the mass times the acceleration in the x direction. Now the acceleration in the x direction is equal to the derivative of the x component of the velocity with respect to time. So we have that F0 divided by m dt is equal to dvx. And now we can integrate in both sides from time 0, when the speed is v0, the velocity in the x direction is v0, to a time t when the velocity is vx. So we have v f0 t divided by m, and this is equal to vx minus v0. So this means that vx is equal to v0 plus f0 t over m. Okay. This is the x component of the velocity. Now we have to find the y component. So we have that fy is equal to 0.3 f0, and this is m a y. So we have 0.3 f0, this is m dvy dt. So we have 0.3 f0 dt is equal to m dvy, and then let me write it as 0.3 f0 divided by m dt is equal to dvy, and I'm going to integrate from t equals 0 when the velocity in the y direction, is 0 to time t when the velocity is vy. So we have 0.3 f0 t divided by m is equal to vy. So we can use the two equations, one for vx and the other one for vy, in order to find the speed at any time. Remember that the speed is equal to the square root of vy squared plus vx squared. We have that this is the square root of vx squared, so that's f0t divided by m plus v0 squared plus 0.3 f0t divided by m squared. So this is the speed at any time. This is the first part. And in the second part, I'm going to find the trajectory, the equation of the path of the particle. So remember that Vx is equal to F0t divided by m plus v0. And also remember that vx is dx dt. Okay, so this is equal to f0t divided by m plus v0. So we have that dx is equal to f0 divided by mt plus v0 times dt, and we have to integrate it from time 0 to time t. At time 0, the position is 0, the particle starts at the origin, and at time t, the position is x. So we have x is equal to f0t squared over m plus v0t. Okay, then we have that Vy is equal to 0.3 f0 t divided by m. So dy dt is 0.3 f0 t divided by m. We have dy is equal to 0.3 f0 t dt divided by m. Then we can integrate it. So we have y is equal to 0.3 f0t squared over m. So we have these two equations. With these equations, we can find what is the equation of the path. So notice that y over 0.3 is equal to f0t squared over m. So x is equal to y over 0.3 plus v0t, which is the equation of the path we were looking for and the answer to our exercise.